In this video, we're going to learn how to interpret two-way tables. Here's our first question. The two-way frequency table below reports information about dessert preferences for two classes of students. Which of the following statements are true? Alright, so we've got several statements, we've got our table. Let's just go through the statements one at a time and look to the table to see whether it's true. Starting with the first statement. First statement, number 1, among all the students surveyed, there were more sophomores than juniors. So where do we look in the table to find this information? Well, the rows tell us sophomores and juniors, so in the totals column for the rows, we'll see the total number of sophomores, which is 125, and the total number of juniors, which is 75. So total number of sophomores is 125, and total number of juniors is 75. There were more sophomores than juniors? Yeah, 125 versus 75. That makes sense. So yeah, this is true. Next statement, number 2, the majority of sophomores and juniors disagree on dessert preferences. Well, let's look to the table to see what does each grade level prefer. For sophomores, 50 of the sophomores prefer ice cream, whereas 75 of the sophomores prefer cake. So the majority of sophomores prefer cake. Let's write that in. Majority of sophomores prefer cake. And then how about for juniors? For juniors, 20 prefer ice cream, 55 prefer cake. So again, 55 is the bigger one, so more juniors prefer cake. And we see that for sophomores and juniors, the majority of them share the same dessert preferences. So no, they don't disagree on dessert preferences, the majority. They have the same preference. So this is wrong. Next statement, number 3, of the students surveyed who prefer ice cream, about 29% are juniors. Alright, so first we need to figure out how many of the students surveyed preferred ice cream. And to figure that out, we can look in the ice cream column, look at that total. Total is 70. So 70 students preferred ice cream. And then of those students, how many were juniors? Well, look in that column, 20. 20 were juniors. Okay, so 20 were juniors. So the statement is really claiming that 20 is 29% of 70. And let's check that out. So 20 over 70. If we punch that into the calculator, the result is about 0.2857, which is rounded to 2 decimal places, 0.29, which is 29%. So yeah, this is good. This is true. Alright, so looking back, which of these statements were true? It's just 1 and 3. So 1 and 3, that is our final answer. Here's another problem. The relative frequency table below reports information about the writing utensil preferences of students and teachers. Which of the following statements are true? Again, we've got 3 statements, and we need to look at the table and determine which of these statements are true, which of them are false. We'll start with the first statement. Among the people surveyed, 85% were students. Alright, where in the table do we find the total number of people surveyed? Well, that's in the totals of the totals column, and that's just 1. Now that doesn't mean just one person was surveyed. Actually, looking at the rest of the table, we've got some decimals here. So what the table is really telling us is these decimals all represent portions relative to the whole. The whole is like 100%, and you can think of these decimals as percents also. So what portion were students? Let's look to the totals of the students column, 0.85. A portion of 0.85 is indeed 85%. So this first statement is true. That's good. Let's move on to the second statement. Among the people surveyed, pens and pencils were equally popular. Let's look at the totals of the pen row and the pencil row. These will tell us the portions of the people who prefer pencil or pen. So for pencil, the portion 0.5 prefer pencil, so 0.5. And for pen, the portion 0.5 prefer pens. So an equal portion of people prefer pencils and pens, and thus they are, in fact, equally popular, at least among these people surveyed. Alright, next up, statement 3, 50% of all teachers prefer to use pencil. So looking in the table, in the pencils row and the teachers column, we see that 0.05 is the portion of people surveyed who are teachers and prefer pencil. But remember that 0.05, that is relative to all the people surveyed. And in statement 3, we're talking about a portion just relative to the teachers surveyed. Now the teachers surveyed, looking in the totals row, the teachers surveyed comprise 0.15 portion of all the respondents. So to get the portion of teachers who prefer to use pencil, we have to divide this 0.05 by the portion of teachers in the survey, divided by 0.15. And we can actually do this one by hand. Just multiply top and bottom by 100 to move the decimal place over a bit. So this becomes 5 over 15, which reduces down to 1/3, which is about 33%. So no, not 50%. It should be 33%. So this statement here, statement 3, is false. And we see that the only true statements are 1 and 2. Here's another problem. The conditional relative frequency table below reports information about students' heights and the sports they play. Assuming each student plays only one sport, which of the following statements are true? Again, we've got 3 statements here, and we'll look at the table below to classify each statement as either true or false. First statement, the table gives conditional relative frequencies for columns. So conditional relative frequencies for columns means that all table entries would be taken relative to the sum of the column. In other words, the column totals should be 100%. Let's write that down. Conditional relative frequencies for columns, that means the columns should sum to 100%. So let's look in our table and see if this is true. Wrestling column, the total of that column, the sum is in fact 100%. Same with football, same with basketball, same with the totals column. 100% is the sum. So yes, this table does indeed give conditional relative frequencies for columns. Next up, statement 2, the proportion of football players whose heights are less than 1.6 meters is equal to the proportion of basketball players whose heights are less than 1.6 meters. Alright, so what's the proportion of football players whose heights are less than 1.6 meters? Let's look at less than 1.6 meters row and then go over to the football column. That's 33%. And 33% is relative to the sum of the column. So 33% is relative to all the football players. So yes, indeed, the proportion of football players whose heights are less than 1.6 meters is 33%. And now we have to compare it to the proportion of basketball players whose heights are less than 1.6 meters. So again, in the less than 1.6 meters row, go over to the basketball column. That's 28%. And that is the relative frequency given that a player plays basketball. So that is the proportion of basketball players whose heights are less than 1.6 meters. So this statement is really just saying that 33% is equal to 28%, which is clearly false. So nope, statement is not true. We can move on to statement 3. Statement 3, there is a possible association between sport and height. Why don't we look at the proportion of players whose height is greater than 1.6 meters in each sport? And we'll just see if there are significant differences in those proportions for different sports. So in wrestling, that's 17%, in football, 67%, in basketball, 72%. So one thing that jumps out to us immediately is wrestling has a much lower proportion of players who are shorter than 1.6 meters. Whereas football and basketball have much higher proportions of players who are taller than 1.6 meters. So it looks like wrestling might be associated with shorter players, whereas football and basketball might be associated with taller players. So yeah, it looks like there might be an association between sport and height. So looking back, which statements were true? Just 1 and 3. So 1 and 3. That is our final answer. So now we know how to interpret two-way tables, and in the future we'll continue working with data. We'll learn about mean, median, and mode.